You gotta look at that. So, let's call this, it's a good way for us to finish today. No, you can't see this. Hang on. That's the wrong remote.
No, projector.
Oh, there it is. Thank you. We're recording, right? We are. All right. So here are a few headlines. I put the link up here. When you have the PowerPoint, you'll have a link too. It's called Headlines from a Mathematically Literate World. Headlines from a Mathematically Literate World. What the author of this website has done is he's grown tired of listening to headlines that are vacuous, that ignore things like margins of error, and he's decided to rewrite them so they're actually truly statistical. So take a look at the first one. Our world. Local heat waves seen a sign of global warming. We've often seen this. How many of you have heard it this fall? From your friends. How many, right? I'm not picking a side here. I'm not picking a side. My beliefs are irrelevant, as are all of ours. I mean, we can have debates about it over coffee. I love that kind of stuff. I really do. But we don't want to share our opinions here. We want to talk about scientific fact. Local heat wave seen as not a meaningful indicator of global trends. That's because a local heat wave, number one, ignores the bigger picture of the variation in the population. In other words, you look at Bert's 100 or his 61 and try to say that is the one distance we should look at and ignore everything else. The 82 is pretty close. Yes, but the 61. Yes, but the 82. Yes, but the 61. Yes, but the 100. Yes, but the 82. But the 100. You can't just cherry pick ones that prove your point. You've got to look at the whole when you're looking at variance. And not just that, you don't just find the locale that had the hottest fall and focus on that. You look at the overriding winter last year is a perfect example. Pacific Northwest winter last year was one of our
Worst.
Worse in what way, Kelly?
Well, not really.
Not as much snowfall as average, right? Warmer than average.
Yeah.
Look at the rest of the country. They got hammered. Pennsylvania was getting huge snowstorms into April. Our little pocket was very warm, but the rest of the country didn't follow that trend, or at least a lot of the rest of the country that usually gets winter didn't follow the trend. They got much higher winters. So should we ignore them and just focus on us? No. Look at the entire package. As a matter of fact, go past the United States, look at it worldwide. Can't cherry pick your data when you're talking about anything, let alone variance, let alone variation. Does that make sense? You guys see what I'm getting at there? I'm not picking a side on global warming. I'm saying if you're going to look at global warming, look at the whole picture. That's all and anything for that matter.
Well, this is written probably by a local newscaster.
Oh, it doesn't.
They gotta make news out of anything pretty much.
This is the problem with 24-hour news, Scott. You see this, how often, when do you hear about global warming trends and going up or down? After either warm winters or wet winters or dry winters. I mean, whenever they are viewed as too extreme, what they've done is they've deviated surprisingly from, say, last year's level. But when you look at the trends over, say, 100 years, it's almost a predictable blip in the system. You will do that in this class with me in about a week. When I give you that data sheet, we'll save it till next time to give it to you. The data sheet that actually has snowfall in Bend over 100 years. And we'll look at those crazy years like 1993 when it snowed like 95 inches in Bend, in the town of Bend. I mean, anyway, we'll get back into it then. But the point is, you can't cherry pick data. You shouldn't. You can. There's pieces all the time. You just shouldn't do it. Okay, Faith? Taking it all in? You okay? Okay, good. Tara, go!
It's my same question.
Go!
Talking about cherry picking. When you take a random sample, how do you know if you're cherry picking or not?
You never do. You never know because you don't know what your population is, right?
So you can't even really trust what numbers.
Oh, no. I think we're saying two different things. It seems like we're saying the same thing. When I say cherry pick, I mean go out and look around until you see data that supports whatever your hypothesis is. A random sample doesn't have goggles. It's got blinders on. You're saying, so just to make it, it's an artificial example, but suppose this room contained the population of whatever I was studying. And let's suppose I was studying the results of a meal replacement group for anorexic teenagers. Let's just to throw that out there. It's a study I read about 6 months ago. Very interesting, actually. So in this room is the population of anorexic teenagers, okay? And we put them all on this, supplement. And I want to prove that my supplement or my methodology works. It puts weight back on them. If I cherry pick my data and I'm looking around, who am I going to put into my results? The ones that put the most weight on, to prove my point. A random sample, I put on a pair of blinders I take a die and I say I'm going to roll the die a number of times, and the numbers that come up on the dice are the samples I'm going to pick. I might get all the ones that put weight on. That would be an outlier if it happened. I more likely will get a representative sample of that population with blinders on. So cherry picking can only happen when you're looking for data that's going to support your hypothesis. Random sampling puts blinders on and says I can't see my data. Now, I'm not saying that we might not get the exact same data. It might happen that way. But it's not intentionally that way because you're not letting
I
yourself
was
see.
thinking about it, you know, when you showed us the randomness things. that
Yes, the clumps.
They happen in clumps, so if you randomly just take a clump of that,
Oh.
it's not.
But what's the chance of you randomly getting the clump? Taryn's, oh, thank you for this. She is responding to, may I jump out of here for a second and come back? I want to address that very point. So her point is, I gotta go back out of here. Her point is a very, very good one. That when you have lots of repetitions of trials, you get clumps. We got birthday matches, yes, in here? Remember that birthday matches we got? Okay, so here is 200 flips of a coin every time I press the F9 button. Taryn's like, if you're studying, what's the probability of getting heads or tails on a flip of a coin? You can zoom in on this right here as your random sample of say 8 and say the probability is 0% of getting heads. It's 0% of getting heads. My point is, although my eyes are drawn to that, I close my eyes and I use a random number generator to generate, say, 30 numbers, and I go in and pick those 30. And the idea of that is, these are what you're going to get if you randomly sample. You're going to get roughly half heads and half tails. You might get, let me see if I can page through, because Taryn, sometimes you do get far, there's perfect 50-50. Hang on, let's just look around. How far apart can we get from 50? That's pretty far. See what happened right then? I sampled a clump right there, yes? I sampled a clump. I got 8%, I got 16% deviation there between the two of them. But that's the rare bird. The rare bird's going to be the outlier. Not the, what you're talking about is what's called a set level of confidence. 95%, 99%, 90% confidence in avoiding an outlier. I'm not saying it can't happen. I'm saying with random sample, you minimize the chance of it happening. Is that fair?
Yeah, I can't think of what I'm.
No, what you're saying is perfect, dude. What you're saying is awesome. You're saying a fact. What you're describing could happen randomly. It just most likely won't happen randomly because I have to be grabbing the outlier.
That was the likelihood of it happening would be on how big of a sample it is.
Generally speaking, yes. But if you draw a larger and larger sample, it's less likely to happen.
Exactly.
Yes.
So how do you know when it's big enough?
You and your next term questions. It goes back to that
I
formula.
like I can't get past it.
It's okay. You should. You think it's 244?
Yeah.
Yes. So sit tight because we're getting there. We are getting there. So Taryn, I got a question for you. Can I tie up the last example with a question to answer your question? How many of you have seen? Whoops. Let's get this thing started up. Oops. A headline like this. Unemployment rate jumps from 7.6% to 7.8%.
Thanks, Obama.
Now, Taryn, I'm not saying that is not a statistically significant measure, but you would have to have drawn a huge sample in order to detect a change that slight. You would have to, the sample would have to be in the 40s, 50s, 60,000s. A more accurate statement is, it's probably a little under 8%. Maybe going up, maybe going down, you can't really tell. I mean, that's honestly what, based on the sample size they most likely drew, that's the truth, because the margin of error is too wide. Does that make sense?
Yeah.
Now, what you're saying is so good. We can detect a change. It's so funny you bring this up. I invented a game 2 weeks ago in 244 to hammer this home. How many deals, if I screw with a deck of cards, if I take a fair deck of cards and take out, put in 4 more aces and take out 4 twos, how many hands would you have to play until you noticed? Right? Right? See, that I arrived at work one day, I'm like, it would be cool to do a chi-square kind of test, but make cards involved. If I took the twos out and put the aces in, how long would it take you to notice that the twos were gone? That's a question. Say that again, Corey.
Depends what game.
That's true, it depends what game. That's good, that's good. So suppose you were just doing the simplest thing of dealing a card, looking at it, dealing a card, looking at it, dealing a card, looking at it. How long would it take you to notice until something was up? It would take a lot more trials to determine something was up there than if I took out every card under 10 and replaced it with aces. You would notice that much quicker, right? The question is how much? What's the mathematical relationship? It's just like the randomness problem in 105. You develop a formula for it. Unfortunately, I've already given it to you because you was a great question last week. But we're still building the ground floor for that as far as that margin of error. We're still there, if you don't mind. I hate to keep doing that to you, and you're always like a term ahead of me. But that's good. I'm proud of you for being that way. All right, more on this on Wednesday, yes?
Yes.
Good. You guys are awesome. Great questions today. Great comments today. Alicia, I'm sorry I made you say that 3 times. You said it perfectly.
Sure you're not
Goodness.